Good afternoon, students. This is Mr. King. I'm going to do the best I can in the next several minutes to teach you a little bit about the pH scale for acids and bases, and also show you how to solve problems that involve pH, pOH, hydronium concentration, and hydroxide concentration. So, before we get started, you need to be sure that you have several things with you. You need to have a calculator. You need to have some scratch paper like this. You need to have your copy of the practice problems, these right here, and something to write with, of course. So we've been talking about acids and bases, and we've discussed several different definitions for what makes an acid or what makes a base a base. Now, if you remember, both the Arrhenius and the Bronsted-Lowry definitions of an acid involved something which either raised the concentration of hydrogen ions or something which released protons. And depending on concentration of these, that can tell you how acidic something is. Now, I think I had mentioned in class at one point that what's actually happening is when you take those hydrogen ions and you put them in water, they end up forming what's called a hydronium ion, H3O positive. This right here is what makes an acid an acid. And if you look at the concentration of hydronium in any substance, that can tell you how powerful or how strong, how concentrated that acid is. So when we talk about the pH scale is related to the concentration of hydronium ions. Now, let me talk a little bit about the scale. You already know that the pH scale runs from 0 up to 14, with 7 in the middle. Any substance which is between 0 and 7 is, of course, an acid. Any substance between 7 and 14 is a base. And then right here in the middle at 7, you have neutral. An example of that would be pure water. What we haven't talked about is where this scale actually comes from and what it means. And to understand this, it's important to understand that the pH scale is what is called a logarithmic scale. Okay, let me see if I can spell that. Well, what a logarithmic scale is, it's a scale where each step along the scale is actually 10 times stronger or 10 times weaker than the scale right before it. Another example of a logarithmic scale you may be familiar with is the Richter scale, which they use to measure earthquakes. But the pH scale is a logarithmic scale. In other words, if you have something which has a pH of 6, and you compare it to something which has a pH of 7, then the substance with a pH of 6 is going to be 10 times more acidic than the substance that has a pH of 7. If I have something that has a pH of 5, then this substance here is going to actually be 10 times 10 or 100 times more acidic. Okay, so keep in mind, we're not talking about a scale like you have for weight or for temperature. This is a scale where even one step is a huge difference in how acidic or how basic something is. And this entire scale right here, like I said, is related back to hydroxide concentration. Let me give you an example. Let's say, for instance, that you had an acid, and if I took this acid and I measured its concentration of hydronium ions, Remember, if we're talking concentration, we're talking molar concentration, which is moles of solute per liter of solution. Let's say that the hydronium concentration for this is equal to 1 times 10 to the negative third molar. Okay? Which means, in other words, if I was to write this out, it would be 0.00, okay, hold on, 1, 2, yeah, 0.001 moles of solute per liter of solution. Okay? Now, this substance has a pH of 3. So how did I get that? Do you see anything up there that might tell you, might relate back to this pH? Absolutely right. I'm glad you guys caught that. Very smart. Yeah, this 3 right here is the same as this 3 right here. And basically what this 3, it's telling us how many decimal places away the decimal is from the number we have here. So if I have something with a hydronium concentration of 1 times 10 to the negative 3, or 0.001 molar, then I am in the tenths, hundredths, thousandths place. It is 1/1000th of a mole per liter, or a pH of 3. If I have something, let's say I had a different acid. And this time, instead of it being 1 times 10 to the negative third, let's say that it's going to be 1 times 10 to the negative fifth. Now 1 times 10 to the negative fifth means it's going to be 0.00001 mole of solute per liter of solution, or tenths, hundredths, thousandths, 1/100,000th of a mole for every liter. Well, this guy, and you've already figured it out by now, would have a pH of 5. Now, if you remember back to our pH scale, it runs from 0 to 7 to 14. Well, the first one we looked at had a pH of 3. This has a pH of 5. You can see that this one is less acidic because it is farther from the 0 end of the scale. And you can also see it's 2 steps away on the scale. It's 2 whole decimal places away from where it was, which is why, oh, I'm not sure you can see that with the glare on that board right there. I'm sorry about that. But this explains why this right here is 100 times less acidic than the one that was pH of 3. Now, good news is the math really isn't much harder than that. The bad news is you're not always going to get these nice, easy numbers to just flop over into something like this. And so you're going to have to use something on your calculator called a logarithm, which will pretty much do all of this for you. Okay? Let me give you the formula, and I think you're going to get a paper that tells you all these formulas, but the pH of a solution is equal to the negative logarithm of the hydronium concentration. Okay, let me show you how to do that. In fact, if you will look with me at, let's go ahead and do number 1. Actually, let's look at number 1B on your practice paper, okay? 1B wants you to find the pH, and it gives you the hydrogen concentration of 1 times 10 to the negative 6th molar. Now, you could look at that, and based on what we just said a minute ago, you could tell me, well, that's easy. That's going to be a pH of 6. But let's see if we can get the calculator to tell us the same thing. So let me turn my calculator on here real quick. Let me clear it out. Okay. So on the calculator, the logarithm button on this calculator is, okay, if you find, there it is right there. It's the second button from the top. Okay. And so what I'm going to do is I'm going to type in exactly what I've got on this. Okay, it's 1 times 10 to the negative 6th. I'm going to take the negative logarithm of that. So I'm going to hit negative button. See if we can get that where you can see it. Probably not. Negative Yeah, this is really annoying with the glare. There it is, kinda. Okay. Negative log. You see it pops up negative log. It opens up parentheses for me. There we go. Negative log, and I'm going to type in 1 times 10 to the negative 6th. Okay, so I'm going to do 1 second EE. Come on, where'd you go? Gosh, this must be fun to watch. It sure is fun to make. Okay, let me back out of that real quick so we can go from the start. Okay, I'm going to hit negative log 1, and I want to do 1 times 10 to the negative 6, so I do 1 second function EE button, negative 6, close parentheses, and I hit enter, and the answer it gives me is 6. That tells me my pH is 6. Well, big whoop, right? Like we said, we could have done that in our heads. Let's look at 1C and just kind of compare that and see if we can do 1C. 1C is a little bit trickier. Okay. 1C tells us that our hydrogen concentration is 6.59 times 10 to the negative 10 molar. Okay. Now that's not a quick, easy number. I can't do that one on my head. Now the fact that it's to the negative 10 tells me that the pH is going to be somewhere around 9 or 10, maybe 11. Okay, it at least tells me what kind of ballpark I'm going to be in, but I need an exact number. So I'm going to do exactly what we did a minute ago. Let's see if we can find it. There we go. Okay, I'm going to clear. I'm going to hit negative log, and it's 6.59 times 10 to the negative 10. So I'll type in 6.59 EE negative 10. Close my parentheses. Come on. There you are. Hit enter. And it says my pH is 9.18 and a whole bunch of other parentheses. So I'm going to call it 9.18. Now that was pretty close to the 10 that I thought I might see. So pH equals 9.18. Okay. And that's my answer for 1C. Okay, so that should at least get you started in if you're given a concentration of hydrogen or hydronium, that's how you find the pH. Now what if you want to go back the other way? Well, just like addition has an opposite operation, which is subtraction, and like multiplication has an opposite operation, which is division, a logarithm has an opposite operation and is called 10 to the x. Okay? And if you look on your calculator, they've made it really easy to find that, because right on your log button right there, you hit the second function of that, and there's the little 10x right over that. So we can go backwards. We can go from pH and find what our hydrogen concentration was. Look on your paper at problem number 2C. Okay, 2C tells us that our pH is 6.60. It wants us to find our hydrogen concentration. So formula for hydrogen concentration, or hydronium concentration, and you can use either one of those, they pretty much mean the same thing. It's equal to 10 to the negative pH power. Okay? So here's what I will do. I will get my handy dandy calculator here, make sure it's all cleared up, make sure you can read it. And I'm going to hit second, 10 to the x, it'll hit 10 caret, it'll open up a parenthesis for me, and I'm going to type in negative pH, so I'm going to do negative 6.60, so negative 6.60, close my parentheses, and it should be something times 10 to the negative 6 is what I'm shooting for. It looks like I've got, whoa, gave me a great big long number in decimal, 0.000000251. Now, if I want that in scientific notation, which I do, I'm going to come up here, I'm going to hit second, and hit the button right next to it, and I'm going to pick psi on my menu. Okay, that'll put it in scientific notation. I hit equals. It's 2.51 times 10 to the negative 7 power. So that's my concentration, 2.51 times 10 to the negative 7. Now wait a minute, King. You said that it was going to be something close to 6. Well, if you look, 6.6 is awfully close to 7. So I know I'm at least in the right ballpark. That answer makes sense. You should be able to do the other ones on part 2 with that. Now you come to part 3 and you come to something which is called pOH. Now pOH is also a scale. We don't often use it because usually we use the pH scale. But the pOH scale is identical to the pH scale except it runs the other direction. Okay? So if you have, say, an acid that has a pH of 4, then its pOH is going to be equal to 10. On the pOH scale, if something has a high number, that means it's an acid. It's exactly the opposite of pH. Well, how did I know that? Well, this is some easy math. You're going to love this. For any substance, its pH plus its pOH always equal 14. So if I know the pH, I just take 14 minus pH, and it gives me the pOH. And vice versa. If I know the pOH, which, by the way, I think I should mention, just like pH is related to hydrogen concentration, pOH is related to hydroxide concentration. Okay, remember that's the thing, according to Arrhenius, that makes a base a base. And so, if you know the pH, it's very easy to find the pOH, and vice versa. So, all of the problems on part 3 should not be a big deal for you. Part 4 is going to ask you to do something very, very similar to what you did in part 2. Let's look on the next page real quick. Actually, it doesn't look like this really is going to make it really hard for you to find pH or pOH. Let me show you just one more thing real quick. And this is another really cool thing about acids and bases. I think it's cool because I like it when numbers do strange things that make it easy for me to remember. Okay, remember, just like, and I just erased this, I don't know why I unerased it, the pH of any substance plus its pOH is always going to equal 14. Well, check this out. Remember, this is tied to hydrogen concentration, right? Or hydronium concentration, H3O. This is tied to hydroxide concentration, OH. If you take, for any substance, its pH times, its hydronium concentration times its hydroxide concentration, it will always give you an answer of 1 times 10 to the 14th power. Which means if you know one of these and you want to find the other one, all you have to do to find the other one is you do 1 times 10 to the negative 14. I lied. Ha. You take 1 times 10 to the negative 14 divided by the one you have, and it will give you the other one. Okay? So, for instance, let's look at problem number 5b, okay? On 5b, it tells you that something has a hydroxide concentration of 3.45 times 10 to the negative 8. And it wants us to find the pH. Well, I can't go straight from hydroxide concentration to pH. Now, I've got two possible choices. I could go from hydroxide concentration to, well, I could go from hydroxide concentration to pOH if I wanted to. And then I could go from pOH to pH by taking 14 minus whatever this is. But another way I could go is I could go 1 times 10 to the negative 14 divided by OH is going to give me hydronium and then I could just use my pH formula to get the pH from this. Either way you do it, it's going to give you the same answer. So let's do it this way right here. I'm going to take 1 times 10 to the negative 14. I'm going to get my calculator. I'm going to wake it back up. Okay, so I'm going to go 1 second EE negative 14 divided by, okay, it says my hydroxide concentration is 3.45 times 10 to the negative 8, so I'll type in, come on calculator, 3.45 EE negative 8, and I get 2.89, or let's call it 2.90 times 10 to the negative 7. So that tells me that my hydronium concentration is 2.90 times 10 to the negative 7. Now remember, to get from hydronium to pH, I'm going to take the negative log of this number. So I'll do negative log 2.90 times 10 to the negative 7. Okay, let's do negative log 2.90 times 10 to the negative 7, close my parentheses, tells me that I've got a pH of 6.54. So the answer to 5B, pH is equal to 6.54. And I've been talking for about 20 minutes. I think I'm done talking. I want you guys to do the best you can, split up into groups. Use scratch paper, follow the examples. If you need to rewind the video, go back and pause it on things. Feel free to pause it on things. And good luck.